Good evening, Professor Muthiah Kasi. Good evening, Engineer Anita Lucas. Good evening, all my dear friends. We have today's guest as Professor Muthiah Kasi. I would like to give you a brief about his profile actually before we start. Professor Muthiah Kasi is an executive member of Alfred Benish and Company. He served as Chief Operating Officer and later as Chairman of the Board of Benish. He is also a professor of practice at University of Illinois at Chicago, UIC. He serves as a board member of UIC Engineering Dean's Council. He teaches advanced bridge design and value methodology for graduate students. He is the 10th recipient of Larry Miles Founder Award since 1963. His design on bridges won more than 20 national awards in the US. He has 2 registered trademarks in economic approaches, which are TQE and for ProValue. He is currently doing his PhD in structural engineering at UIC. He worked with Thomas Snodgrass in advancing customer function model. Recently, he published his advanced thinking in strategic approach using function analysis. He developed VM value methodology standards for ASTM International. He has published 4 books on value methodology and several engineering publications. And indeed, we are all blessed with his presence today. He's one of the most senior professional in this stream. And we are all fortunate to have him today here. I would request all of you to be very complete participation in this session. Please make sure that you have a very good internet connectivity so that you won't miss out a little bit of this lecture. And from start to end, it is very important. You're going to get a lot of information out of this session. And I would request Professor Muthiah Kasi to come forward and start his presentation.
Thank you. Before I open my PowerPoint, I want to thank again for giving me an opportunity to talk about it. It is one of my favorite technique for the last 45 years. And every time somebody asks me to do it, I'm always happy to do it because it's one of the things I wish we all use it all the time, not just in projects, but in the rest of life. And I always say function analysis is almost like a mathematics. If somebody asks you, when do you, apply arithmetics, rest all your life you do that, all the time you do that. The same thing, it's a logical thinking. With that introduction, let me share my screen. Okay. Today and tomorrow, we're going to talk about function analysis. And it's a function model, and function cost today. And then tomorrow, strategic function and function cost. It'd be a little bit of overlap. First thing I want to kind of give the perspective, value methodology. I mentioned yesterday that maybe participant today may not have been there yesterday, so I'm going to repeat it. Value engineering is not just an engineering technique. It's a value analysis, could be used in any walk of life. It's a logical thinking, and it always asks how to do certain things and why are you doing it. The why part is really the power. And that fits in the value methodology job plan. It has the information phase, function analysis, speculation or creative phase, evaluation, development, and presentation phase. You may see me going a little faster with my talk, and the reason is this particular subject, what I'm going to cover today, is usually an 8-hour teaching session. So I'm trying to kind of give a brief one. So excuse me if I go too fast with my talk, okay? Or I'll try not to, but the nature is I may do that, okay? Now, Anita Lucas, next week, she's going to talk about the entire job plan from information phase to presentation. What I'm going to do would be function analysis, which is the key aspect of a differentiator of any strategic method. Okay. Larry Miles, who found the value methodology in the 40s for General Electric, gave a real quick one. And GE during the war couldn't cope up with replacing parts when the wall was broke. And he was able to ask the question, what does this do? And he came up with the different things to substitute so that the parts, he ignored the parts and looked at the function. And he also said, if you cannot say your message in 2 to 3 words, you may end up contradicting or confusing your critical thought. The more, if you write a 1 page, you may get into the trap. So that's where he started this function analysis. And he asked the question, what does it do? Or what should it do? What does it do is if you are given a project or a design and you want to do a value analysis, you ask the question, what does it do? But if you don't have anything else, somebody asks, well, I wanted to design a building like an architect or engineering in bridges. Then you say, what should it do from the client? Okay. Now, you always have to kind of be very precise in your definition. The needs and desires and constraints of owner, user, and other stakeholders will contradict each other. And to make it in project perspective, you had to say it in 2 words, a verb and a noun. And when you get that function, there may be functions that are work, and there are functions which are self. In good old in the 80s, we have found that only work. But today with the smartphone, you have a lot of functions, nothing to do with the phone, but those are self functions. Work functions is an active verb and a measurable noun. It's a quantitative statement. Self functions are passive and non-measurable, that's qualitative. When you get to the example, you will understand a little better. The first section, what I'm covering is kind of real abstract. Give you an idea, at the airport terminal, a late arriving passenger who's late for the flight and the need is to get to the gate quicker. What are the functions? He or she want to seek line priority. That's a verb and a noun. Expedite screening, verb and noun. Facilitate passing. That's the way the message is given. So the passenger say, seek priority, expedite screening, facilitate passing. And now next is, if you're a smoker at the airport, you need to smoke. Now the function and noun is based on the stakeholder. The smoker function is to relieve tension. The non-smoking passengers and the Environmental Protection Agency regulators want to protect the environment, exclude air, dispose air. And those functions, then you can allocate to the cost and say, what do I really need to do? Second thing is, like I said, you have to be very precise. If you say safeguard pedestrians, it's half the information because we don't know what kind of pedestrians are. But you have to be more, say, safeguard children, safeguard elders, safeguard disabled. That means the total intent is given. So if it's a safeguard children, you may have a crossing guard and a guide to manage the safety. Safeguard elders means if you have a signal with a passing walk, you give a longer time for them to walk. The safeguard disabled one, you may have a special design. As you can see, the noun can change the solutions. Okay. Another example is if you say provide lock in a house, first of all, provide is a word that doesn't really, it's not active. Now, provide lock, if you give that function, the possibilities are you may install a deadbolt, install a security bar, install electronic keys. These are the possible ones. But instead of provide lock, if you say secure home, now you can have all those 3 ones, but then you can have a camera, you can hire a security guard, you can inform police when you go away, be friendly with your neighbor, or do not. These are the possibilities. Suddenly the 3 goes into 9 or even more. So that's the power of the function. A quick example, what you're looking at a pier for a bridge. Now the pier, if you look at it, there are 6 components. You have the parapet and a deck. Then you have this steel, you have a pier cap. Then you have a column. You have a wall, and you have the foundation piles. They all, this one receives the load and resists the load and transfer to here. This one, again, doing the same three things. In here, in addition to that, it also distributes the load to different columns. Then this one not only do all those things, but it also protects the pier if somebody hits it. So it is designed for that. So you have this. Usually this kind of a pier is used when you enhance appearance. But if you don't have to enhance appearance, you can basically take the pile foundation all the way through and you put a deck. So here, receive, assist, transfer is all done by one component. When you look at this one, this is not even in a critical path. This is just to come back and protect it. This can be done in an industrial area. This is a simple thing. The cost difference between these two is because we eliminated the component that has the same function. But in addition to that, enhanced appearance is important in areas, then this solution will not accept. So that's the way you are going to look at it. It also here is expedite construction. So that's kind of a simple introduction to functions. Now I'm going to talk about the function model. What that means is you got all these functions listed based on the user owners, stakeholders, needs, desire, and constraints. Now you classify them. What is more important? Now, FAST diagram is a term that used for both of them called a function analysis system technique. But I will not use that term, but you may see that there. I would either call it a function model or a strategic function analysis. What is a FAST diagram? It's an expression of one or team's perspective of an issue or a purpose. It's a communication tool, and it's also a strategic tool. A FAST diagram is a logical assessment of process that will strategically lead you to possibilities. FAST diagram is not a flow chart. Sometimes people do use it as a flow chart, okay? Now, one of the things that people always ask in the workshop is that my diagram is right. So long you follow the verb and noun and the classification things, there is no right and wrong FAST diagram, so long you follow the ones. What it really is that your perspective of what do you think is the purpose and need of a project. Okay? There are two types of analysis. Today, I'm going to cover the function model. Tomorrow, I'm going to do the strategic one. So let me stay with the customer function model. Now, the function model has, Tom Snodgrass developed this one in the late 70s, and then I worked with him quite a bit to shape this one, modify, and so forth. What it is, no matter what you look at it, there's always a reason you do, that's a task. But there's then a basic function, then you make them dependable, convenient, satisfaction, and attract. And what is a satisfy stakeholder? Everything, one of the things that confuses people say, well, we do everything to satisfy stakeholders. That's not what it really means here. What it really means is if it is not a basic function, if it is not dependable, if it is not attractive, if it's not convenient, I'm doing it is because I had to satisfy. So satisfy stakeholder is really should be a minimal if you want to be cost effective. Okay, now I'm kind of go through that. The task is the overall need of the project and why you perform a particular project, okay? The basic function is the absolute minimum you had to do. So if I took a high-rise building, just the structural aspect is all you need to the basic function. Because if I have just that, nothing else, people can occupy, it will take the load, you can put all your furniture, everything. But is it dependable? Or is it convenient? Is it attractive? No. So, but that's a basic function. What you need to know, when it's all done, you have to say, how much of my total cost goes into the basic function? If it is an industrial building, there will be more cost to the basic function. If it is a museum and other things, there will be much less. So that's a basic function. Now, the second thing would be what makes it dependable? Makes the element stronger or more reliable, make it safer to use, lengthen the life of the project, protect the environment. So now that means that same building, now you enclose it so that exclude the weather, and you can do a lot of things in it, and that will, excuse me, that will make it dependable. But now, if I had to walk through the staircase for 40 stories, it's not convenient. So now the convenient function, before I go there, I'm sorry. When you look at the function of one, mechanical arm will lift the weight. It will perform the basic function, but it cannot balance the body. So when you have a natural hand, an arm, it not only lifts the weight, but it also makes it dependable. That's kind of a way you have to look at the dependability. Convenience, air conditioning, elevators, and all those things will come under the function convenience. And how much money we do to make the building more spatial, meaning instead of a 8-foot ceiling, you may have a 10-foot ceiling, or you may have a 14-foot ceiling, and you facilitate the maintenance and furnish the instructions and so forth. They all come under convenience. Now, it's a simple example. If you're in a parking garage, you have a circular column versus a square column. The circular column, they take the same load. Both perform the basic function and dependability. But if I park the car next to that, opening the door, I would be more closer, and it's convenient to get out. But if I see a sharp edge, I will be very hesitant. I will squeeze myself out. So that's the difference between what a convenient is. Also, the VE is not just to reduce the cost. It is really managing the cost to satisfy the people's need. That means it can increase or decrease depending on what people see as a value. Now, satisfy stakeholder, modify the basic functions to satisfy the individual desire. Somebody putting a glass elevator outside, it is really not dependable. It may not be convenient. It may not even be attractive, but it is something that people feel it's the opinion of the stakeholder, not necessarily the designer. If that's what the client wants it, you have to do it. But you have to say, in order to satisfy you, we may have to spend 15% of the total cost. So that's the thing. Now, all perception will come under satisfy stakeholder. That is a perception, safety-wise. People feel if it's a square column, somebody could hide behind when I walk by. But if it's a circular, I can see. But when you ask the security consultant, they said, no, if somebody want to attack you or something, they can move around. So it is more of a perception. So the cost difference between these two will go into, say, safety perception on a satisfied stakeholder. Now, attract stakeholder is basically your senses, what you feel, what you look, what you hear, all those things will come under the attract. Attract stakeholder is one of the things is in the eyes of the holder. So really that's where the subjective of value will come into picture. If you look at the old telephone, that performed the basic function and dependability. Now, today's ones make it more convenient because you carry with you. It satisfies stakeholder with the music, camera, and so forth. It's attract stakeholders handy. Now, if you ask, depending on the stakeholder, if you ask the old generation, they're going to say, well, I like the landline because I always don't know where my phone is. But if you ask the youngsters, they're going to say, I don't want that bulky. I should be able to access it anytime you want. So here you can see the dependability is, again, depending on what the stakeholder thinks. Okay. Normally, a project have basic function 10 to 20%. And when it's, the variation will add up to the 100. Convenience is about 5 to 25, depending on what you do. The reason I'm saying it, if this industrial building, it may be 5. If it's a train station, it may be 20% and so forth. Satisfy stakeholder, if one individual making decision of the entire project, there'll be less of satisfy stakeholder. But if you have a group of people, like particularly a government-driven project, there may be more people making to satisfy, and the satisfy stakeholder goes much higher. Okay. Now, here's a bridge in Shanghai in China. what you can see, it's a 100 kilometer per hour. The opposing traffic do not have any barrier or not even anything, just a stick. That means assured dependability is not given that important, but the money went into attract stakeholder. Now, is it a wrong project? No, that's what the client wants it. And also the community, knowing that they are very careful when they are driving, there's not much of an accident. It is still dependable in their eyes. But if you ask a very conservative designer, they would say, well, it's not very safe to drive. Now, in US, opposing traffic, in some cases, not only they are separated by two bridges. That's the extreme of assured dependability. So you can see how the variation, that cost will go up for dependability in this and much less in here. Same thing with the retaining wall. You can have all type of you can have a driver sheeting that will retain the earth that perform the basic function and dependability. But for convenience to sit on top, attractiveness, you have different things. Again, you have to see what the client really wanted. I'm going to, watching my time, I'm going to skip this part of it quickly because I like to cover something more important. When you look at the drain water, if it's a high speed, you may have a hydroplaning, so drain water is dependable. If it's a 30 miles per hour, it's more of a convenient. If it is an individual house, it is to satisfy stakeholder. If it's a museum or amusement park or Disney World, it is to attract stakeholder. They don't want to drain. So that's the kind of things. Now, the next thing is when you look at all these different type of transportation, look at the animals and the plant and so forth, and the car and the mother carrying a baby, they all have the same basic functions and tasks. And what it is facilitate travel. And how do you do that? You initiate movement and control movement. So we want to keep your function such a way, all the solutions are applicable to the function. So that's kind of a summary of that. Now I'm going to move on to the next one. This is a project we did. City of Chicago wanted to have the transit train goes underneath the parking garage into the train station for CTA. So that means this is the existing parking garage. They want to excavate underneath, leave all the foundation, and thread a station inside. So the station will, here is a 5-story building. Underneath, here is a foundation. And they want to excavate the dirt and build a box shape one and leave the columns, foundation, and put a platform. Now that's a given as designed. The first thing what you want to do would be, what does the design as designed do? So I'm going to walk you through. If this is the way it will look, all this foundation, this is an old station somewhere else. Okay. Now that means all the utilities, HVAC, everything would be underneath the false ceiling. So that means if the maintenance person have to work on it, he'll be working underneath. So look at the passengers have to put up with this one and a non-rush hour and also all the column. So I looked at the fast diagram. What's the task is to access the airport. How do you do that? You receive the passenger and disperse the passenger. How do they make it dependable? They protect the building above 5-story by not touching the foundation and safeguard the passenger by lighting from the ceiling and manage obstructions with the proper guidance, and they house the utilities in the ceiling. What I colored is the one the VE is going to change. Maintain circulation is not very convenient with the foundation in the middle. Minimize disturbance is not performed because of the maintenance people are in the way, and facilitate maintenance is not done properly. So that's also the false problem with as given. In the satisfied stakeholder, minimize traffic impact. They had to excavate the dirt, store it somewhere, build the one, and bring it back under the airport traffic. Second thing is, it doesn't not attractive because this concrete wall will have cracks and there'll be leakage. You have to constantly do that. That's the way we analyzed this one. And now we came up with what we did was, okay, we are going to eliminate the foundation. That's a shocker to people. I said, okay, we're going to do certain things so that there won't be any column. That's our design. And then I'll walk you through how we did the function to come up with a solution, but I'm giving the solution, then give the function. What we said, okay, we're going to excavate and not bring back the dirt. So that means half the disturbance is gone. Then we're going to build a post-tension girder. Okay, here is the existing foundation. Away from the foundation, we're going to build a new wall and build a new post-tension girder. We post-tension it, lift the column slowly, and cut the foundation. That's the concept. I'm sorry, I'm only going through, if anybody interested in the structural part of it, that's a session by itself. So we did that. Now, this is the way the things will look. Not only we put a glass wall, and inside we put all the HVAC in both sides, and we put a drainage inside, so when the water drains, it drains here, so there won't be any drain here. We put a lighting here, we light the glass, so it look like a natural light, and that ceiling has nothing there, so it's really, okay. So our basic function is still the same, the C passenger, okay. And we did the dependability, the same thing, but we protect the building in a different way. Now, we improve the circulation by eliminating the obstruction and separate the activities, maintenance versus the passengers and so forth. The things that I forgot to mention, when you go from left to right, it's a how. How do you improve circulation, eliminate obstruction, and separate activity? If you go the other way, why do you eliminate obstruction and separate activities to improve circulation, to make it convenient to access the airport? That's a logic you go. You also, how do we facilitate maintenance? We isolate utilities here, and we improve access by having a door every 300 feet or 200 feet. So again, you ask the question, why do you isolate utility? Why do you improve access? It's to facilitate maintenance. Why do you do that? To assure convenience. Why do you assure convenience to access the airport? Then minimize traffic impact because we're not bringing the dirt back. We facilitate the construction because half the backfill is not there. We improve the spatial quality by optimizing the height, shifting the foundation, projecting natural surrounding. So that's the way it was done. Here is the existing column with the foundation. We build this one, we post-tension it, slowly lift it, and slowly cut this one. It's a very unique design, but the VE process was able to do that. That's the way the airport looks now. There's no column protruding here. And this one, President Reagan's Presidential Award for most innovative architectural design. So that's just to give you the effect of a customer. This all, we were looking at each function and we addressed how do we really change the, come up with different solutions. So now I'm going to go to, I was planning to shift this one since I had the time. I'm going to go through this example, which is basically a simple example. Some of you might have seen it on Sunday, but I'll go through this. Okay, here. How do you really design any component? Like we designed this CTA station, but that's just kind of a very elaborate to go through step by step. But same step I'm going to explain with a simple one. In a highway, you have a shoulder. A shoulder, it has multiple functions depending on what you have. What I'm going to show you is in Chicago weather where there's a lot of snow and so forth. So you can see when you're doing this in Chennai or other places, some functions are not going to be there, but it just kind of give you an idea. Here's the traffic and you have a shoulder, okay? Now, if you have no functions, I shouldn't say, there's no shoulder here. That means whatever the functions that you want are not here. So if you did this one, you basically did a cost reduction, ignoring all the functions. And as you can see, as the truck's going through the traffic, heavy load, it kind of shattered the end. So as time goes on, the pavement start deteriorating a lot more. So the very first thing what you want to do, you want from the lane, you want to put a 2-foot shoulder that will protect the pavement. So function of the 2-foot shoulder is to protect the pavement. Now, if you are in winter conditions, you want to be able to store the snow on the side. So it's aid the operation. You add another 2 feet, but you have to keep in mind when you're looking at snow storage, they both are additive. 4 feet we can store, but out of which 2 feet you are doing it for protect pavement, you can stop there, or you can go another 2 feet. Now, the next thing is you want to, house a disabled vehicle. Now, in this case, you add another 4 feet. So now you have 8 feet. When a car is disabled, it uses 8 feet. However, the 2 feet is for a multiple function. Or in other words, this 2 feet has both house disabled vehicle and protect pavement. This 2 feet is to the storage, and I'm sorry, this one will have, if I have the cost of the 2 feet, let us say it is on a long highway, $500,000, I will take it 2 out of 8 for this, 2 out of 8 for this, 2 out of 4. Then you also add moving vehicle. So now you want to have a little bit more, another 2 feet. Now you have a 10 foot for access for emergency, okay? Now, if you want to be safer when you're changing the tire and so forth, to facilitate maintenance, you add another 2 feet. Depending on the type of highway, the standard is either 10 feet or 12 feet or 8 feet. That's all based on the functions. But now, one of the things that you may want to do, how do I really allocate all the functions? If I have a 12-foot shoulder, with that ratio of 2 out of 12, 2 out of 12, 2 out, so you can share it proportionately. But there are times where the client says, we don't have any snow, we don't care about other things. We are doing it because we have too many accidents. We want to have a wide shoulder for the ambulance and fire trucks to come slow. So the entire cost, I'm doing it for the one. See, this is where the subjective function cost distribution comes in. Now with that one, let me go to the last one. I'm going to go, since I'm looking at the time, a lot of what I covered it, I'm going to kind of slowly go through the same thing in this example. So if you miss a little part of it, hopefully that I have repeated here. I'm looking at a water filtration plant. One of the things that I would like to really pass on my opinion is, the thing is that we are all using Excel spreadsheet, Word document, PowerPoint, and everything. I feel the best way to communicate what you learn is really graphical. The graphical representation of any project is very, very important, and that's kind of the hidden theme of this example. So I have a filtration plant. Instead of giving a Word description and Excel spreadsheet with a cost estimate, I said, well, I'm going to do it everything graphically. What you see, this graphics would be used all the way through the function cost, and so forth. What we have, a city which has a problem with water shortage during summer and peak summertime. And they draw their water from a reservoir, which is also shared by 4 villages. So 4 villages pick this one. So Ashland is one of the 4 villages that wanted to improve their part of it. So what they did was they dug 3 wells and took that one, and they took it directly to their filtration plant so that it is not shared under the reservoir. Okay, that's number one. That's one of the needs and desire. The second needs and desire, they have an existing tank. which every year, 2 weeks, they had to take it out of commission to maintain. At that time, they really had to borrow water with the trucks from other villages, which they don't like to do that 2 weeks. So they said, well, we're going to create a new 1 million gallon tank similar to what the village has. And that will also increase the pressure, and it does other things. So that was the design, okay. Then they'll take it to the filtration plant and the sludge lagoon and so forth. And then they also talk about metering so that people who use more could pay more. It'll discourage them from wasting the water. So that's a description that I can give. Now we take the same thing, okay. Now I'm looking at what does this cost? I'm placing the cost here, $752,000 for the tank. Now, right now, the village engineer said, we don't want to pay for the transmission. We'll take it an open ditch for $42,000. And the wells to improve is for $12,000 and so forth. And you can see the metering is $500,000. And these are, so what I'm saying is now what I described, all the costs, where they go. Now we're going to say, okay, why do I want to spend $178,000 here? Why do I want to spend all these things? Now I'm putting all the functions, major functions relate to that. For demonstration purposes, I did not list all the functions, so bear with me. Now, before I do that, like I said, the village say, we want to satisfy drought conditions. We're going to pump the water, but we're going to take it in open ditch for a cost of $42,000. Okay. Now, what happened is it does not meet a certain function. There is a loss due to percolation and evaporation. It's also these two functions, contamination and reduced loss. These are the needed function. This is where you are going away from cost reduction to value engineering. So we said, okay, you're going to spend from $42,000 to $178,000. You're going to increase it almost 4 times to put a transmission line. That will reduce the loss, prohibit contamination, satisfy drought conditions, because in here you're sharing with other villages, whereas here you're taking directly to your own plant. Okay, so that with that one, now you can see the functions of all this one. What's the function of the major function of the tank is to back up fire protection, facilitate maintenance, maintain pressure. And also maintenance is where the 2 weeks when they are not using it. Facilitate fire protection is they want to be able to, when it is down, if there is a fire, they should be able to draw water from there. So which is to you really a dependability function. Now you can see the other functions. Facilitate metering is to promote conservation, conserve water, simplify operation. Here, assure quality, control temperature, secure area are all the functions. This is where we ask the question, what does it do? Now where we take the total cost, all these costs, we said, okay, and we take all these functions and we allocate it. We said backup fire protection is similar to what I showed the shoulder example. There's a logic behind the distribution. The facilitate maintenance is that much and so forth. Here, the transmission line, the 178,000, reduce loss equally given to the 2 ones and so forth. So what you are not learning from me today, how did we get it? If this is it is very similar to the shoulder example, but it's a lot more complex. There is a judgment on why do you really do it. And they could have said, oh, I'm doing everything to prohibit contamination, so I'm going to put the total dollar there. You can do that. Or you can say, I'm going to put it between the 2 and so forth. So there's a subjectivity, and you can see all of them. When it is all done, this is, can you see the expanded version? I'm going to blow it and then bring it back. The function of the water, the entire project is to satisfy demand. And how do we do that? We collect water, transfer water, and assure quality. So those are the three basic functions. So the total cost of that is certain amount. Then we said, okay, what are we going to do to make it dependable? This is based on a swale. So we did not spend any money to all these functions. And then conserve, these are coming from the water tank. And this is again coming from the water tank, okay? Then in the convenient functions, we minimize the treatment, access the facility, maintain pressure, simplify operation. Those are convenient function. Satisfy stakeholder, facilitate maintenance, because there is always, they could have gone to another village and do it, they're doing it. Same thing, facilitate metering. So when this is all done, 6.25% went to attract stakeholder. Satisfied stakeholder was 13.8, convenient is 19.45, and dependability is 39, and rest of them is a basic function. Now, this is the opinion of the customer. The customer thinks the backup fire protection is really a dependability function. But when the VE team looked at it, they disagreed with the customer or the client. And the reason is the fire protection is controlled by volunteer firefighters who are common to all 4 villages. So no matter where the fire is, they're all coming from one place. So they can easily pick up the water on the way. They don't have to come here and pick it. So the team said, we're going to move that fire protection to satisfy stakeholder function. It's not, this is the power of communication. Some people think it's dependability, and the VE team say, okay, here are the reasons that you can be dependable with what you have, because the firefighters, when they leave their village, they can pick up the water. So we did not change the number, but we moved here. So suddenly, satisfied stakeholder went up to 30%. So that kind of flags that's an unknown, it's an unwanted function, and the unwanted cost you're doing it. It's not cost effective. However, the team said, we are disagreeing with the customer about putting the water on the sail, water in the swale. We like to have the transmission. So they added the 172,000, what used to be 0 for prohibit contamination, reduce loss, and part of conserve water, it came back. So now suddenly the cost distribution is slightly different. Now the final resolution is that function backup fire protection was gone. It is eliminated. So the satisfied stakeholder is back to 16%. And you can see why the 16, the facilitate metering to begin with, they're not going to charge extra. They're just going to survey the one. But in the future, they're going to charge the client. Then it becomes more of a dependability, and the same facilitate metering may end up in the dependability as a conserve water. Conserve water is here. The metering costs would come here once everybody accepted. This is the way this diagram is communicating. You put the diagram the way you see it, and then start moving them around so that people can see when you move a function from one to another and what happens. Okay, so that's okay. So now this is to summarize what we have done. Customer perspective, they thought by fighting the fire with the extra tank, they put 39% on dependability and 13% satisfied stakeholder, and their total cost is 2.4 million. And the team first said, okay, we're going to leave the backup fire protection, but we're going to move it to the satisfied stakeholder from 340 added the cost of the one. And we're also going to add the transmission line. So the team first took it, added the 170,000. So the cost increased from customer perspective to team perspective. However, team did not agree that you should not, here's the reason the client wants to do it. The reason you're doing it step by step, if the client is willing to spend 2.6 million, God bless them, they can have their extra tank, extra water to fire, they feel good about it and nothing wrong. But what we have shown the client is, are you doing it, you're not doing it for dependability as you think, you're really doing it to satisfy yourself on a perceived safety, perceived backup. So do you want to spend that much money which does not have return on investment? And finally, the council agreed with the team perspective, and it was taken out, as I said. Now the cost went from 2.5 to 2.1 million, and the satisfied stakeholder function remained, but the other proportions now, even not only the cost went down, the ratio of went up to where you should spend money. What that really means, anytime you spend more money on basic and dependability in any project, you are very, very stingy in spending the money. So normally you would see the total could be around 60 to 65%. Convenience, depending on the usage of the one, and this, as low as you can would be great. And then the attract stakeholder, again, depending on how you want to make this look as nice as you want. So that's kind of the function model, function classification. And I went a little faster. So if any of you, I'm going to open up the chat. So if any of you want me to cover a particular item, and I'll be happy to go back.
Yeah, something from Runali. Runali, do you have something to ask? You can go ahead.
Hi, good evening, Kasi sir. Yeah.
Good evening.
First of all, I really appreciate the examples which you shared with us, and I have few questions that examples which you have shared. So I just wanted to know the, the process of, going the value functionality of all these projects. So what all are the details processes which we need to, go through to, identify the major objective beyond that value engineering. So what are the keys and objective as well as the processes which we need to follow?
You mean in the process, what's the process you follow?
Yeah.
Okay. So first of all, you need a team. Value engineering should not be done on an individual basis. It's a team effort, and that's a number one. Number two, you have to have a set of rules, which Anita Lucas is going to cover, but I'm going to answer you in a couple of minutes. You always have to have a series of things. One of the reasons we find the difference between normal thinking and VE process thinking is we are all trained to jump to a conclusion because we are under pressure. When there's a problem, everybody wants to show off to say, I know the answer kind of thing. That's the first thing you want to stay away from it. And you have to ask, there is a series of questions that you had to ask. And the questions are, what is it? What does it do? What does it cost? What should it cost? What else will do the job? Will it work? Can I sell it? Okay. These are the steps of the job plan. When you're doing it, what is it and what does it do? You cannot go into what else will do. And no matter how good and how confident you are with your solution in your mind, you had to list all the solutions to prove that where your idea is in there. And I'm going to give a quick example of the what is it. You may not, most of you know the hallmarks, the greeting cards and so forth. The hallmark people came with a coffee mug to do a value engineering. So my first question to the team is, what is it? And their answer is, what do you mean, what is it? The mug is a coffee mug. I said, no, Hallmark is not selling coffee mugs to drink coffee. They do it as a media. So I said, call your office to say, do you want to do a V of a coffee mug? Then we can come up with a tall mug, small mug, transparent, square, circular, and on and on. But if this is the media to express your feeling, then you can go, coffee mug is one way of doing it. You can have a mouse pad and t-shirts and so forth. See, that's where the function, what is it? It's the same thing when you go into a sidewalk in a place. If the sidewalk is used by commuters, it's one kind. If the sidewalk is used by senior citizens and handicapped, it is different. So you have to ask the project, what is the project you're trying to do? What is your objective? Then you go into the function analysis and what the function. Also keep in mind, when you do it in the beginning, you got to do the baby steps, meaning you can just list the functions and do the VE. You don't have to do all the elaborate thing what I talked about, because that's a second, third, fourth step. To begin with, if you have a team that is new to the VE process, just to list some functions, what does it do? List all the functions and say, for each function, like I have it in that CTA train example, facilitate circulation. How do I facilitate circulation? Widen the platform, eliminate the, when I said eliminate the foundation, shift the foundation, people jump to, you can't do that, and a speculation, you cannot judge it. So that's the thing, is that when you do the VE, in the information, you collect information, understand. In speculation, you do not judge. In evaluation, you do not create, but you judge it. Then you package it to market it to convince the people. So that's a process, kind of not. But like I said, Anita will go through this whole thing in a lot more detail in the 2 sessions.
Yeah, thank you.
Well, Thibaut Thomas, do you have something to ask?
I got, yeah.
Yes, sir, go ahead. No issues.
I have another question. Can I, jump to the one?
Sure.
By Ramashri. Is there a cap limit to the percentage for each of the cost distribution? The answer is no. It's a guide. The reason is, when you do a similar project, you can guide them. What I have shown is more like a transportation project. But if this is a museum, attract stakeholder maybe 30, 40%, and satisfy stakeholder could be more. And if it is a industrial building, Tata is building something just to move parts, there may not be any, the dependability and the basic function may be 80%. What that really does, once you get it, remember you ask the question, what is it? You know the profile of what the client wants the building to be. Then is that the way the money is spent? Because there are water treatment plants, they spend 15% on attract stakeholder, museum and so forth. Is it really needed? The answer is no. So that's where it really, there's no cap for that. What phase of the project okay. And let me see what I can pull that slide from yesterday's presentation. Can you see this slide?
Yes, sir.
Okay. The question is, what phase you can do the VE? There's no really, you can do it at any time, but if you do it from a planning to schematic to design development and construction, the further you go, the effort is needed more, the cost to make the changes would be more. The best time to do would be on a planning phase, where things are not really committed. And there's 2 reasons for that. One is there's not effort put in, so it's not a waste of throwaway effort. Second is psychologically, people, once they committed, they own the authorship of that particular idea. They're going to fight not to change. So the best phase is planning. Even though we have done it all the way through, halfway through the construction, so it could be done at any time, but the earlier you do, the better. The process is still the same. But if you do it in the planning, you're going to say, what should it do? Because you don't have the design. But if you have a design with you and you're doing it, then you say, what does this design do? What should my design would do kind of different? But to answer the question, it can be done anytime. The sooner, the better. And,
Right. Chibu Thomas.
Yeah. Can I?
Yes.
Am I audible?
Yes.
Yeah. Good evening, Muthiah sir. It was a wonderful presentation. Understood. I just going back to the previous question, which now I'm clear on that. You said that it can be done at any phases. My question is, okay, if we have constraints, like we are in a construction phase, right? We're having so many constraints in terms of specification, in terms of contract drawings. If I refer back to your example of bridges, right? You show on bridges in states which you are showing pier cap piling all over there, and you said that okay, it can be all. It's all for architectural features only. You can straight away do the pier to keep the deck straight. But I would say, okay, are we taking care of all the forces on that deck? Are we taking care of the moments? Are we taking care of the horizontal forces? No, these all are requirements, right? In terms of bearing, all those components are required to have the load transfer.
Okay, I did not show the plan, but let me explain to you. You're right. The reason when you have these piles, they are very slender, but this particular ramp is in a circular shape. It's a clover leaf one, so that the geometry itself gives the stability, number one. Number two, when you have the decorative, the concrete one, the spans were 40 to 80 feet. When you have the pile, what I showed, it's limited to 30 feet. I didn't get into the engineering aspect of it, but the main thing is if you're trying to change it in the construction phase, the client has to agree. But most of the time, this is where I'm saying that's a wrong time to do it because the specification and also the contractor is committed to certain subcontractor for the concrete guys and all of the things that he's not going to change it. So it really, those are the constraints we have. But in the US, what they are saying is they give you value engineering change proposal to the contractor. What that means, during once the bid is accepted, the contractor can come up with a VE, and if they save the money, half the savings goes to the contractor.
Okay.
So let me just take this example. Let us say this one, concrete would be $4 million, but if I do the steel, it would be, say, $3 million. The contractor can come up with it, and the $1 million savings would be shared $500,000, for which he has no effort. So he'll be encouraged to do it, and we're doing it a lot more on DECP, where the contractor calls us and says, okay, can you look for some, but we have to really satisfy all the function, because if the function enhance appearance is one of the function, the client will reject the proposal. But if the enhanced appearance is not a function, then they'll accept it. Yesterday, I don't think I have, but I don't think I'll have it here. We have one where we actually saved $1 million to the contractor. Before he even start the project, he walked away with $500,000. Or after all the effort to change the design, about $400,000 he walked away before he started the project. So that incentive is needed. That's part of the specification. Go ahead.
But agree with you. But the question is again the liability part, right? If I am in the construction, example for a bridge, for me, I was doing a balance cantilever bridges. I changed it into a span by span. Span by span method of erection is very faster, right? Compared to the balance cantilever erection. So it is a saving which we offer to the client. But end of the day, when something goes wrong in terms of erection or in terms of any structural deficiency comes, the liability pass, the client can always question on the liability. Okay, is there any code in value engineering, code of ethics or any standards which support that? I know it's US, it will be very easy. which everyone will recognize maybe, but all part of the world, do you have any code of ethics to support our value engineering methodology? If you put it forward to the client, make it faster, like we have the STM codes, we have the specific, n number of codes. Astro code is there, Astro is there, right? So like that, any code is there to support value engineering, make it faster.
No, even there, the code Astro does not, Astro just say you can entertain a value chain change proposal. But in US, when a contractor comes up with one, it has to be reviewed by the designer and accepted. And they will throw all the questions you just said about stability, fatigue, redundancy, and all the things. And once they pass the test, the liability still stays with the designer and the owner. And the contractor still, they can, in US, they can sue anyone, but the technical liability passed on, because if the designer rejected, and if the owner go ahead and did it, then the contractor is responsible. And in here, the contractor will not take it unless the designer accepts it. Some modifications and so forth. And also, the contractor will hire a designer to do these changes. That designer is liable. Their insurance will cover their liability. So mainly when you talk about the code, it's a process you need to define where the responsibility, number one. Number two, the project insurance should cover it. Construction project insurance covers everybody who's involved.
So no, there's no technical code as it is, but it's all covered with the insurances or fatigue code or sort of contractual things, right? It's
no, also there will be a specifications on VECP. In there, it will spell out the responsibility and who is responsible, who is liable. So when the contractor looks at it, if he thinks that it's liable, he's more liable, he will not propose a change proposal.
Preet K. Laurel. Preet, it's your turn. You there?
Am I audible?
Yes, Preet. Go ahead.
Yeah. Hi, sir. It's an honor to meet you. So my doubt is regarding the second case study that you showed. You explained the construction of an underground metro station beneath a building. So clearly the initial plan was quite a simple one without much demolitions or anything, but you chose a more elaborate one in which a transfer girder was constructed in order to create a column-free area. So wasn't the second option way more expensive compared to the first one? So in this, was value engineering based on the usability of the product? Is it like that, sir?
No, actually, I think the schematic is kind of misleading. We were able to save $2 million savings.
Oh, okay.
And the reason is the depth of excavation, taking it under the heavy airport traffic and find a place to store it, then bring it back and fill it is major cost, labor cost.
Okay.
And the second thing is, in order to, that box carries more than 15 feet of, 10 to 12 feet of dirt on top. So that has a load. Whereas in ours, we just took it all the way, there is no dirt. So if I can, some other time, if I can do an engineering and I can show, not only that, what we did was that transfer girder does not have any farm work. Before we excavate, we build the girder, then we excavate it underneath. Okay. So there are a lot of, like I said, there are a lot of little creative ideas went into save a $2 million savings. I don't know what's the total cost, but the cost difference is about $2 million.
Okay. Okay, clear, sir. Thank you.
Yeah.
Right, Mr. Raghu Gauri.
What is an EPC contract?
Sir, it's engineering, procurement, and construction.
Engineering, procurement, construction. So that means they all come under one.
Yeah, like a turnkey.
Okay, so that's the best way of doing a VE, because in ours, design, bid, and build, you may have a planner and then a designer, then you have the contractor. Whereas in the EPC, you have all of them. And here we call it a design build project, which is the same as EPC. The contractor generally bid the job. They will hire a value engineering team to VE, and based on that, because here is the thing that a drawback with a traditional design build, the designer doesn't know which contractor is going to do it, because some contractor is very effective in concrete, some are in steel, some are that kind of thing. Whereas the contractor can specifically design it to their strength, and so that they have maximum profit they could do. So EPC, like a design build, is the best opportunity for a design, VE process. And again, what we find we don't even call it a value engineering anymore, because it kind of upset people. They say, well, whatever I do engineering, we call it a function analysis. Whatever the function you're doing it, we're going to do a function cost. And that's, so EPC is the best way to do a VE.
Yes, go ahead.
Thank you, sir, for this wonderful presentation. My question is, if value engineering is all about the team, but if a team individual code for some different value at that time, which value we have to, means at that time, which value we have to take so that it can be good for the client as well as for consultant?
It was really broke up for me. I couldn't hear half. Can Nebu or somebody can say it again?
Can you repeat it again, Tanya? Even I couldn't hear the whole thing.
Keep it a very simple question. What specifically? It's that way. Then I can elaborate on it.
I think what she meant was how could value engineering be adopted for both the benefit of both the client and the contractor. Is that right?
Yes.
Is that right?
Yes.
Okay. Generally, how do I say? Clients sometimes put constraints on construction in the specifications. So the contractor is going to look at that specification and build it. But if the client can change the specifications, for example, let me say in the highway, in the US, sometimes they would say you have to maintain 3-lane traffic and you have to build your bridge. The cost goes up because the contractor has to look at the safety of the workers and all the things, and they had to do it on a night. That goes cost up. But the contractor say, okay, if I can basically reduce to 2 lanes instead of 3 lanes, my cost will come down, and they can have a value engineering proposal. And the client will look at it as, okay, I'm making up my numbers just to explain. Okay, let's say that by reducing from 3 lane to 2 lane to 1 lane, there may be $1 million difference between each time. And the contractor said, okay, if you give me 1 more lane, I can reduce the bid cost by a certain amount. And this has happened, and the client comes back, okay, I will rent you the lane per hour. So whenever you need, you can rent it for X amount of dollar. So what that really does, if they don't put that one, the contractor is going to give me, I'll keep the 2 lane for the whole year, even though they may not need some time that make more inconvenience to their client. But by saying, I am accepting it, but you have to rent it, what happens is the contractor will only use when they need and still have the savings, they pass it on to the client. So it is a team effort. The problem we find with the VE where one or the other are not benefiting if they don't work as a partners. Partnership is one of the spirit you need between the owner, the designer, and the contractor, if builder. I don't call it a contractor, I call it a builder. Everybody is in a contract. So the builder, designer, and the owner have a partnership to see how could we work together to change the constraints, change the needs into a minimum so that we all can benefit. So it can be done, and it has been done.
Sir, I put the question because Thibu was asking for the code, and I mean, maybe you could mention that the ASTM standard and even the federal law that that there is on that A1131 on value engineering, sir?
No, that does not address liability.
Yeah.
First of all, ASTM is not a code. ASTM
Code,
is a
yeah.
standard. It's a standard. You have an option to follow or not. So you can put the ASTM standard within your specifications. Then it becomes the contract. So even ASTRO is very careful in saying anything that gives a black and white on liability. They said, for example, I'm just saying, they say, well, when you're designing a beam and you could do a span over 30 is a one, but then they say, if this is a guide, if you want to violate this, you have to do analysis. So the code is written such a way they don't lock themselves into things, and that is just interpretation for them. That's why I think, but specifications, you can write it with the ASTM building economics, what Anita is talking about, has more than 30 standards in building economics. And some of them are how to deal with the uncertain costs, how to minimize the risk. And they even say the risk as a management risk, engineering risk, financial risk, and how you do it. But they're all guide. In fact, ASTM standard guide, that's why they call it certain one standard practice, they call it. So it is really not going to, we're not going to escape from liability just by that. But if you put it in a contract with a specification, then that will cover it. Nice to see you back, Anita.
Well, anybody has any questions? So I request all the participants, come forward and ask your doubts. It's a very rare occasion. It's not very easy to get Kashi sir all the time. So this is a very, very, good opportunity for you to get a lot of information with regards to this topic. And it might sound quite a new topic to many of us. But if you look at the kind of infrastructure development in India, you would really come to know, you would really understand why value engineering is very significant, more significant in the coming days. Today, we had a session in the morning. There was a small concern which was raised. Why was a particular bridge constructed, on a main highway in Kerala? A couple of bridges are constructed. If you look at the functionality, if you look at the purpose of it, it's not serving the purpose. If this particular topic comes into play, then the functionality is always, analyzed, and based on that, they could arrive at cost. There is just one example. So I believe that all the engineers should be aware of this, and they should go through some kind of training wherein you can all design and develop according to the basic requirements and the functionality and all that. So anybody has any doubt, or should we?
No, I have something in a closing, but when you're done.
Yes, sir. That's good.
Today we're talking about how to classify the functions, where the cost is going, and so forth. Tomorrow, it's kind of what Nimu was talking about, is whenever you, whether you build a bridge or a building or whatever it is, the strategically, you had asked the question, what is our objective to doing it? And if you remember, or if you have gone through, there is a technique called a KPI, Key Performance Indicator. KPI has the 4 areas: the finance, operation, human resource, training, and so forth. Now, part of it, in each one, they ask the question, what is the objective? What is the initiative? What is the target? What is the measurement? Those are the 4 areas. So tomorrow, we're going to talk about the objective, target, and initiative and measurement, using it. So that means in a truly a big V effort, you do the function classification to see, yeah, I got more money spent on dependability, or I do not have enough for whatever it is, what the issues are. Then he said, okay, now how do I really solve that one, which I didn't go through today, but the technical FAST diagram as SAVE International has, I have modified that SAVE International to more strategic function analysis, where by changing the objective, by changing the function, you come up with an entirely a different solution. So I will show a few examples. Again, the thing is, in 1 hour, only so much I can express, but I'll try my best. I felt a little bad to go. I thought I went a little faster, but hopefully everybody got a understanding of what I tried to convey. Thank you.
Right, sir. Basically, as Kashi sir mentioned, 1 hour is not good to give you the complete thing actually. But in the recent coming future, we might conduct more classes on this. And I had actually discussed with Anita Lucas about this, and she's also willing to contribute in this regard. And I would like to actually read out one email that I received from Kashi sir this morning. This morning, Nebu, I'm very impressed with you and your editor have done today. I left India when I graduated from Coimbatore. My wife and I feel good when we can give back to our mother country. I felt bad that I couldn't do this year. You opened the door to participate this year, Kasi. And
Thank
it's
you.
it's a true nationalist, a true patriot who really want to give it back to the society. Well appreciated, sir. It's hats off to you, sir.
Thank you. And also, like you said, Anita has the training program, VMF1, VMF2, and those are really will expand. And I think that's another area that, to furthermore, and you do have things available in India. So we'll see you tomorrow.
All right, sir. All right. Okay, thank you so much, sir. Thank you for that enlightening session. Thank you so much for being here. Thank you all the participants. We'll see you tomorrow. Good night.
Yeah, thank you. Thank you, Kashi sir. Thank you.